Jai Hind students, how are you? I hope you all will be fine at home. Am I right? Okay. Students, today I am going to start my very first video lecture of grade 11th. So, let's start our very first chapter of grade 11th, that is sets. So, before starting sets, I think you must know about collections. Do you know what are collections? Okay, students, in our everyday life, we often speak about some collection of articles. For example, your geometry box. Is it a collection? Yes, it is a collection of mathematical tools. Your school bag. This is also a collection of notebooks and books. Your school. This is a collection of students. Library. It is also a collection of books. Zoo. Zoo is a collection of animals. So there are lots of examples of collection in our daily life. So the definition of set is a well-defined collection of objects is known as set. So what is the definition of set? The definition of set is a well-defined collection of objects is called set. What is set? Set is a well-defined collection of objects. Now question arises, what do we understand a well-defined collection? Means what is the meaning of well-defined collection? How can we identify the given collection is well-defined or not a well-defined collection? So I am taking some examples here. Some examples of collection are, I am taking some example of different collections. Very first collection I am taking natural number less than 5. First collection I am taking natural numbers less than 5. Second collection I am taking rivers in India. Third collection books written by Munshi Premchand. Munshi Premchand. Next example of collection I am taking 5 most talented writer of India. So beta, there are some examples of collections. Natural numbers less than 5, rivers in India, books written by Munshi Premchand, and 5 most talented writers of India. So all these are some collections. But now my question is, out of these collections, how many collections are well defined and how many are not a well defined collection? So see, natural numbers less than 5. What are those natural numbers which are less than 5? We all know that. Natural numbers are what? Natural numbers are all positive integers. That means natural numbers start from 1. So natural numbers less than 5 are 1, 2, 3 and 4. Because there are only 4 natural numbers which are less than 5. Rivers in India. If I'm talking about rivers in India, so you can take the examples of Ganga, Yamuna, Satluj, Jhelum, etc. These are the rivers in India. Now, books written by Munshi Premchand. Munshi Premchand. Have you heard this name before? Yes, you have heard. So, the books written by Munshi Premchand are Gavan, Godan, Namak Ka Daroga, etc. Gavan, Godan, Namak Ka Daroga, etc. And the last example, 5 most talented writers of India. 5 most talented writers of India. So, I am leaving this example right now. First, I am explaining natural numbers, rivers, and books. So, see, if I am talking about natural numbers less than 5, so what will be your answer? Your answer will be 1, 2, 3, and 4 only. Okay. Now, if you ask the same question from any other person, so the answer will be changed or will remain same? Tell, answer will remain same or it will be changed? Yes, answer will remain same. If you will ask this question from anyone, then answer will remain same. That are 1, 2, 3, and 4. That means it is a well-defined collection. Now, rivers in India. If I am talking about rivers in India, so Ganga is a river of India or not? Yamuna is also a river in India. Satluj is also a river in India. Jhelum is also a river in India. That means they all are the rivers which flow in India. That means the answer of this question will also remain same for everyone. Okay, now books written by Munshi Premchand. Munshi Premchand has written so many books. Out of them, some are here: Gavan, Godan, Namak Ka Daroga. So, answer will remain same here also. If you ask from anybody, then these books will be written by, these books will be the answer of this question or not. So, here answer is same. That means all these 3 example of collections are well-defined collection. But 5 most talented writer of India. If I am asking you, okay, who are the 5 most talented writers of India? So, in your opinion, Pandit Jawaharlal Nehru will be the most talented writer. Sarojini Naidu will also be the most talented writer. But for me, Tulsidas may be the most talented writer. Rahim Das ji will most talented writer. So, the word most talented is not a well-defined here. So, the answer of this question vary from person to person. That means it is not a well-defined collection. It is not a well-defined collection. Understood? So, well-defined collections are those collections in which the elements remain same for everyone. Means, if the elements of any collection remain same for everyone in every condition, that means that collection is known as well-defined collection. But if the elements of any collection vary from person to person, that means that collection is not a well-defined collection. Hope you are understanding this, friends. Now I am taking some more examples here. So you have to identify out of these collections, how many collections are well-defined and how many are not a well-defined collection. So I am taking the very first example, that is a collection of prime numbers less than 10. Okay. Now what do you think? The prime numbers, the collection of prime numbers less than 10 will be a well-defined collection or not a well-defined collection? Yes, think. Yes, what is your answer? Very good. You are correct. Prime numbers less than 10 means the collection of prime numbers less than 10 is a well-defined collection, because we all know that there are 2, 3, 5 and 7. There are 4 prime numbers which are less than 10, and these elements of this collection will remain same for every person. Am I right? The prime numbers less than 10 are 2, 3, 5 and 7, and it will remain same for each and everyone. So this is a well defined collection. Understood? What happened? Yes, I know. You don't know prime numbers. Am I right? Okay, I'm telling you. Prime numbers are those numbers which are having exactly 2 factors, 1 and the number itself. So see here, 2. 2 is a number which is having only 2 factors, 1 and the number itself. Similarly, 3 has also exactly 2 factors, 1 and 3 also. And 5 and 7, both the numbers having exactly 2 factors. That means 2, 3, 5 and 7 are prime numbers less than 10. So this answer will remain same for each and every. Okay, now I am taking the second example of the collection. The best cricketers of India. The best cricketers of India. So, if you ask this question from me, then for me, Virat Kohli can be a best cricketer. But for you, Rohit Sharma can be a best cricketer. For someone else, Mahendra Singh Dhoni can be the best cricketer. So here, the answer, the elements of this collection vary from person to person. So here the examples, here the elements of this collection may vary from person to person. That means it is not well defined. Clear? Now the third example, vowels in English alphabet. So we all know that there are only 5 vowels in English alphabet. So what are those vowels? A, E, I, O and U. So there are 5 vowels in English alphabet: A, E, I, O and U. So these elements will remain same for each and everybody. That means it is a well defined collection. So this is well defined collection. Now next example is different types of triangles. Different types of triangles means the collection of different types of triangles. So here the elements of this collection can be scalene triangle, equilateral triangle, isosceles triangle, obtuse angle triangle, acute angle triangle and right angle triangle. So how many types of triangles are here? 6 types. These are equilateral triangle, scalene triangle, isosceles triangle, obtuse angle triangle, right angle triangle and acute angle triangle. And these triangles will remain same for everyone. That means it is also a well defined collection. Now the last example is the most dangerous animals of the world. The most dangerous animals of the world. So the word most dangerous, the word most dangerous will not remain same for everyone. For me, lion can be the most dangerous animal, but for you, a lizard can be a most dangerous animal. For animal, for someone else, rat can be a most dangerous animal. So here the elements of this collection may vary from person to person. That means it is not well defined collection. Understood? So again I am telling you what are sets. So set is a well-defined collection of objects. Now we can easily identify which collection is well-defined and which collection is not a well-defined collection. So only a well-defined collection of objects is known as sets. Hope you are getting this. Understood? Okay students, now we will discuss some examples of set. As I explained to you, a well-defined collection of objects is called set. So the example of set is collection of natural numbers less than 100. So the collection of natural numbers less than 100 will be a set because it is a well-defined collection. This is the very first example. Second example, collection of all letters in a word mathematics. Collection of all letters in a word mathematics means if I am asking what are the letters used in a word mathematics, so M, A, T, H, E, M, A, T, I, C, S. These are the letters and these letters will remain same for everyone. That means it is a well-defined collection, or if it is a well-defined collection, so it will be a set. Third example. Collection of all prime numbers less than 20. The collection of all prime numbers less than 20. So this is also a well-defined collection, or if it is a well-defined collection, so it will be a set. Hence, these are some examples of sets. Understood? Now, we will discuss how to represent a set. How to represent a set. So, there are some points you have to always keep in your mind. The very first point is any set can be denoted by only the capital letter. The sets always denoted by capital letters, and the elements of that particular sets can be separated by comma, and all the elements are enclosed in curly bracket. What I am telling you, the set is always denoted by capital letters. For example, there is a set A, so we will denote it by capital A, and the elements of that particular sets are separated by some commas, and all the elements are enclosed in curly bracket. So these are three important things what you have to always keep in your mind. Every set is denoted by capital letters. Elements of that set are separated by commas, and all the elements are enclosed by the bracket. For example, suppose that there is a set A. This is a collection of all prime numbers less than 10. So we can denote it A equal to curly bracket start, collection of all prime numbers less than 10. So we have to write all the prime numbers which are less than 10. So what are they? 2, 3, 5, 7. So what was the very first point? The set is always denoted by capital letters. So I am writing here capital A, and all the elements of that particular set are separated by commas. So we have to put comma in between two elements, and all the elements are enclosed by curly bracket. So we will start curly bracket here, and after that we will close that curly bracket. So this is the representation of set. By this method we can represent any set. For example, all letters of mathematics, it can be represented by, so a set can be represented by the capital letter. So I am taking capital B. You can take any letter, A, B, C, D, whatever. So I am taking B, but it must be capital. So B equal to all letters of mathematics are enclosed in curly bracket. So we will start curly bracket. All letters of mathematics. So we will have to write all the letters used in mathematics. So first M, then A, then T, then H, then E, again M. Again, the very important thing you have to keep in your mind, no element should be repeated whenever we will represent it in a form of a set. No element should be repeated. So here M is repeated, so it is already written here, so we will not write again. A is also repeated, so we will leave it. T is also repeated, so again we will leave it. I, so we have to write here. C, we have to write here, and S, we have to write here. The element should be enclosed in a curly bracket, so we start the curly bracket here. So now we will close that curly bracket. And the third thing, the elements of the set are separated by commas. So we have to put here some commas. So this is the representation of the set where all letters of mathematics are present. Understood? Hope you are getting this or not. Now students, one more important thing you have to keep in your mind, that is, if suppose that there is a set A, 2, 4 and 6. So if I am asking how many elements are present in this set, so there are 1, 2 and 3. 3 elements are present. First element is 2, second element is 4 and third element is 6. So here, if I want to write 2 is the element of set A, or 4 is the element of set A, or 6 is the element of set A. So mathematically, how can we write it? So if 2 is present in this set, that means it is the element of this set. So mathematically it can be written as 2, and there is a Greek symbol like this. This is a Greek symbol. This stand for belongs to. What is the meaning of this symbol? Belongs to. So 2 belongs to A. Is that clear? 2 is the element. 2 is an element of this set, so it can be written as 2 belongs to A. Similarly, 4 is an element of this set, so we can write 4 belongs to A. Similarly, 6 is also an element of this set, so we can write 6 belongs to A. Now, 7. 7 is not present in this set. That means 7 is not an element of this set. So how can we represent mathematically? So we will write 7 doesn't belongs to. Doesn't belongs to means we have to put this Greek symbol and we will cross it. So 7 does not belongs to A. This symbol stands for not belong to. This symbol means belongs to and this symbol means not belongs to. We will put this sign when the element is not present in that particular set, and we will use that symbol when the element is present in that particular set. Understood? So this is a symbol of belongs to and this is a symbol of not belongs to. Hope you are understanding this. Okay students, now I am taking one more example. There is another set A. These elements are A, B star, C, P and Q. And there are some blanks. You have to fill these blanks with the help of belongs to symbol or not belongs to symbol. We have to fill these blanks with the help of these two symbols, belongs to and not belongs to. I explained you where we have to put belongs to. If the element is present in this set, then we have to put this sign, means belongs to. Or if the element is not present in that particular set, then we will put the sign of not belongs to, means this symbol. So first, A, small a, belongs to or not belongs to capital A. So see, this A is present in this set, so we have to put this sign belongs to. Now B belongs to A or B not belongs to A. B is present here, so it belongs to A. Are you thinking this? If you are thinking this, that means you are absolutely wrong, because here B is written but B is not present in this set. Here this is B star. This is what? B star. But here only B is there. So single B is not present in this set. Here B star is present. That means this B is not an element of this set. That means B not belongs to A. So B not belongs to A. Now C star belongs to A or not belongs to A. C is here and C is also here. So again, but here what is? This is not ordinary C. This is C star, and C star is not present in that set. That means C star is not any element of A. So we will use not belongs to sign. So here C star not belongs to A. D belongs to A or not belongs to A. So check, D is any element of this set. D is present in that set. A, B star, C, P and Q. D is not present here. That means D is not any element of A. So D not belongs to A. P belongs to A or P not belongs to A. So P is present in that set. That means P is an element of A. That means P belongs to A. Similarly, Q belongs to A or not belongs to A. So check, Q is present in this set or not. So A, B star, C, P and Q. So Q is present here. That means Q is an element of this set. That means Q belongs to A. Now I hope this concept is clear to everyone or not. Am I right? Is it clear to everyone? Students, now we will discuss about the representation of sets. What I am saying? Now we will discuss about the representation of sets. But any set can be represented by two methods. A set can be represented by two methods. The very first method is known as roster form. The very first method is roster form, and the second is set builder form. So there are two methods for representing a set. First is roster form and second is set builder form. So first I am explaining you the very first method, that is known as roster form. But in roster form, the elements of any set are listed together, and these elements are being separated by commas and are enclosed within a curly bracket. What I am saying? I am repeating again. In roster form, the elements of a set are listed together and all the elements are being separated by commas and are enclosed within curly bracket. For example, a set of all natural numbers less than 10. A set of all natural numbers less than 10, and we want to represent this set in roster form. So I explained you that in roster form all the elements of this set are listed together. So first we will consider this set is denoted as A, for example, equal to all the elements of this set are listed together. So we have to write all the natural numbers less than 10. As we all know that natural numbers start from 1. So the very first natural number will be 1, then 2, 3, 4, 5, 6, 7, 8 and 9, because the condition is all natural numbers less than 10. So we have to write all the natural numbers less than 10. So in roster form, first we will listed all the elements of this sets together. Now these elements are being separated by commas. So we will put comma in between every two elements. And all these elements are enclosed within a curly bracket. So if we will close these elements in a curly bracket. Now this is the roster form of this given set. Understood? I am taking another example. So another example is a set of all factors of 12. A set of all factors of 12. We want to represent this set in roster form. So we will consider any letter, that is B, capital letter. B equal to, first of all we have to list off all the elements of this set. So what are the elements? All factors of 12. So we should know what are the factors of 12. So everyone knows 1 is a factor of 12 or not? Is it true? Absolutely correct. 1 is a factor of 12. Another factor of 12 will be 2. 2 is also a factor of 12. 3, 4, and after 4 what is the factor of 12? That is 6. And after 6, 12 is a factor of 12. Am I right? So first of all, we have to write all the elements of this set. What are the elements of this set? All factors of 12. So all factors of 12 are 1, 2, 3, 4, 6 and 12. Now, after listing the elements, we will separate all the elements by commas. So we will have to put commas in between every two elements. Now, we will enclose all these elements in a curly bracket. So this is the roster form of the given set. This is roster form of this given set. Hope you are understanding this. Am I right? Okay students, after roster form, now we will discuss about set builder form of any set. So in a set builder form, every element of a set have, means if I want to explain the set builder form of any set. So in set builder form of any set, every element of a set has a unique property. Means every element of that particular set has an unique property. For example, if I am taking a set A, E, I, O and U. This set is in roster form. So here all the elements of this set have a unique property. And what is that unique property? The unique property is all these elements are vowels. All these elements are vowels. So I am saying that all these elements are having a unique property. So why this is a unique property? Because no other letter has this property. We know that in English alphabet only these 5 letters are vowels and no other letter is a vowel. So only these 5 elements are having this unique property. So in set builder form, if we want to convert it in a set builder form, so what we will do? First we will have to put a curly bracket. Now we will put here one variable, any variable. It can be x, y, z or whatever. So I am taking x. So in set builder form, we will start from curly bracket and we will put a variable here x such that now we have to write that unique property. What? Vowels. Vowels is what? X. So x is a vowel in English alphabet and curly bracket close. So this representation of set is known as set builder form. Okay, I am taking another example. Consider another example, that is B set is equal to 2, 4, 6, 8. So here all the elements of this set has a unique property. What is the unique property here? See, all these elements are even number. So what is unique here? But this condition, this property is incomplete yet. All these elements are even numbers but less than 5. So these are even natural numbers less than 10. The unique property of these elements are they all are even natural numbers less than 10. So why I am saying these elements are having unique property? Because apart from these elements, no other number is an even natural number which is less than 10. So that means these elements are having unique property. So its set builder form will be B is equal to, we will start curly bracket, put a variable here x, such that now we have to write the unique property. What is x? X is an even natural number less than 10. So x is even natural number less than 10 and curly bracket close. This is the set builder representation of this set. Taking one more example. Here we will consider another example. For consider C is any set and its elements are 5, 25, 125 and 625. Clear? So we want to convert it in a set builder form. So its set builder form will be C is equal to curly bracket x, such that x equal to, x is what? See, x is 5 to the power n. 5 to the power n. X is what? X is 5 to the power n. So see here, this 5 will come if we put 5 to the power 1. 25 will be 5 to the power 2. 125 is 5 to the power 3 and 625 is 5 to the power 4. So the unique property is they are in a form of exponent of 5. So C is equal to x such that x is equal to 5 to the power n. But what is n? So n, 1, 2, 3, 4, they all are natural numbers. So n belongs to capital N. Capital N is a set of natural numbers. So x such that x is equal to 5 to the power n and n belongs to n, means n is a natural number. But natural numbers are infinite. 1, 2, 3, 4, 5, 6, 7 and so on. But here I am taking 1, 2, 3 and 4, only 4. That means n is smaller than 5. So this is the set builder form of this set. C is equal to x such that x is equal to 5 to the power n. They are in the form of 5 to the power n. Where n is natural number, means power of 5 is natural number. 1 is natural number, 2, 3, 4, all are natural number. But we know that natural numbers are infinite. But here we are taking the natural number till 4. So n is smaller than 5. This is set builder form of this given set. Hope you are understanding it. Am I right? Okay, students. Okay, students. Now I am going to wind up this video. The remaining topics we will discuss in our next video. Hope you are enjoying my class. So after this video, I will provide you one assignment based on today's topic which we have already discussed today, and you have to complete that assignment and you have to prepare notes on the topics which we have discussed today. So we will meet again in our next video. मिलते हैं ब्रेक के बाद.